All right, simplify rational expressions, monomial factors. So the first thing we have to do is we have to see what we can factor out of this problem. So I'm writing it down right now. Okay. All right, so here's the problem. The top is a monomial, so we can't factor that, at least immediately. The bottom, so we can factor out of here. So we have 36 and 27. The greatest common factor out of 36 and 27 is 9. What's left over? 9, actually I'm going to go one step further. We can also pull an x squared out. So 9x squared times what is 36x cubed? That is 4x. And then 9x squared times what is 27x squared? That is 3. And on top we have 9x squared still. So you can see now we have a 9x squared and a 9x squared. Because anything over anything is the same, you just cross off and equal 1, we can cancel out 9x squared over 9x squared. So what we're left with is 1 over 4x plus 3. That's the first step of the problem. Okay, so to type it in, I would hit the division button right away. 1 on top, and 4x plus 3 on bottom. The next thing we have to figure out is which values of x make the expression undefined. Your denominator is 0. If you remember, if you divide anything by 0, 4, or it could be x, really, anything by 0, it's undefined. Undefined. Wrote that out terribly. That's undefined. Sorry. So what we're going to do is we're going to set our denominator to equal 0 and solve for x. So 4x plus 3 equals 0. That's there. Subtract 3 first. And then finally, we're going to divide by 4 on both sides. So x cannot equal negative 3/4. If it were to equal 3/4, okay, so we have 4 times negative 3/4. Oops, that's not 3. That's 3. Plus 3, we get 0. So if we put in negative 3/4 into our equation, we'll get a 0 in the denominator, which means our equation is undefined. So we cannot have a negative 3/4. And we're waiting. Even when we're in the afternoon, it's still slow. Oh, I forgot something. When I factored originally, I need to rewrite. I just erased it while I was waiting. Okay, so going back to the board. When I factored out the 9x squared, we cancel the 9x squared from the top, right? We cross that off. However, when we're still, we're talking about what we cannot have, we can't have a 0 here. Because we set 9x squared equals 0. We divide both sides by 9. We get 0. 0 over 9 is still 0. And then to get x by itself, we square root both numbers. The square root of 0 is 0. So x can also not equal 0. All right? Whenever you have a monomial up front like this in your denominator, it'll always be 0. That we cannot have our x equal to. And to focus is not the numerator. It's only the denominator. We do not care what's in the numerator. It's only the denominator. And now we're right. There we go. All right, next question. All right, negative 7n squared over negative 14n squared minus 35n. All right, so we're going to factor out. The top is a monomial. We can't factor out immediately. Actually, it's a 7. It's prime, so we can't factor anything out. The bottom, we can pull out a negative 7. What's left over is a 2. Oh, actually, I'm going to pull out an n too. Sorry. Negative 7n what's left over is 2n, because negative 7 times 2 is negative 14, n times n is n squared. And then over here we're going to get a positive 5, because negative 7 times 5 is negative 35. We can see, I'm going to rewrite this with everything right next to each other. It's a negative 7. So we can cross off the 7. We can cross off 1n, so I'll make that into a 1 now. Okay. And what we have left over is n over negative 2n plus 5. Now, what number cannot be put into here? Well, let's solve 2n plus 5 equals 0. We subtract 5, we get 2n equals negative 5, and we divide by 2. So n cannot equal negative 5 halves, as well as that 0. Don't forget that original 0 from the first part of the question we canceled out. So 0 and negative 5 halves. And the numerator, sorry, the answer is going to be n divided by negative 2n plus 5. And what did you wrong this time? Oh, I forgot the 2. Right here. Jeez. There you go. That should be the answer. All right, I'm having a rough going this assignment. All right. When I rewrote this problem from here to here, I forgot to include a negative right there. So our negatives should have also dropped off. Cancel the negatives as well. That's what I made a mistake on. So, going back to the problem, this should not be negative. It should be positive. And there we go. Everyone makes mistakes. All right, next question. Let's see if we can get one right. Okay. Okay, so now we're just seeing who is factoring appropriately. Okay, so I'm going to write it down. So right away, look at Giannis. You can see what Giannis did. They just canceled out the negative 40z's out here. You can't do that. You can't, when you're dividing like this, unless it's multiplying into it, you can't just cross off the back end of it. So Giannis is wrong. So we're going to see if Shota is right. Okay, so the first thing we can factor out up here is an 8z. What's left over is 2z minus 5. And then down here we can also factor out an 8z. And what's left over is a 3z minus 5. The 8z's cross off. 2z minus 5 over 3z minus 5. And that's exactly what Shota has. So Shota is right. Got one right. And last question. Okay, this one's actually kind of easy. Over 5. All right. So we can factor out a 5 from the top. We get 5 on the outside, z plus 11, and a 5 on the bottom. What cancels out? Our 5s cancel out. We're left with z plus 11. Going to the denominator, there's no variable here. So we can accept all values. There is no bad value because it'll never equal 0. So z plus 11 is our answer. And none of the above. All values will work. And we're done.